Great. Good morning, Professor Nyberg. Hi, Ranadeep. So I'm here to present my capstone on a blockchain consensus simulator under my advisor, Professor Lane Shi. So starting with what is a blockchain? Blockchain is a chain of immutable transactions. And the basic property that blockchains have is that they're decentralized, which means that any addition to this chain would only happen when all the entities involved in the protocol agree with the new transaction. And how the parties agree is through a consensus protocol. To highlight how important consensus can be, let's take the example of Bitcoin, where if you can attack the Bitcoin consensus, it'll allow you to steal Bitcoin, redirect them, or even create a denial of service attack. So to hammer down this point further, that consensus is important. The crucial thing is it decides scalability. So we often see that if the underlying consensus protocol is not scalable, when high traffic occurs, the time of processing a single transaction is driven up, and that drives up the gas fees. And so that would be a major roadblock in the mass scale adoption of blockchain technology in the future. Moreover, consensus protocols are also the main contributing factor to energy consumption in this technology. Our problem is that consensus is hard. It has a lot of moving parts, a lot of parties involved, several rounds of message exchanges. And this is when we're not considering faults. When you have faults in the picture, it's very hard to differentiate between a failed node versus an unresponsive node due to some network delay. In blockchain technology, consensus is even harder because blockchains are publicly accessible, which means that nodes can intentionally deviate from the protocol. This is the hardest condition of fault tolerance to beat, where no assumptions can be made about the behavior of the adversary. So let's get on the same page about what does hard mean. Hard means that this problem is hard to solve. Consensus has stayed a relevant problem in computer science for decades. And CS researchers are always looking for new methods to attain consensus in a simple manner. Moreover, it has been very hard to understand. A famous example is that of Paxos, which in today's world is synonymous with consensus. It is used by Google and Amazon to sync up their data centers. But when the paper first came out, it was rejected by all top conferences because nobody could really make sense of it and its utility. And the author actually took like 3 years to simplify the protocol and had to resubmit it to get it accepted. Moreover, even in the academic setting, professors often have to dumb down the protocol just to teach it. So it is rendered impractical because so many restrictions have to be imposed just to simulate it in the academic setting. It is also hard to implement and test. People often depend on popular solutions because even if you miss out a single detail, the protocol can be vulnerable to attacks. And it is hard to test because it is very hard to emulate a distributed setting, and it can be very compute intensive as well. So in that sense, any testing that could have aided understandability is also out of the picture for most cases. And understandability is crucial because that is how you analyze the security vulnerabilities in the protocol. So basically, that's what we tackle, the understandability problem. Our goal is to develop an interactive framework to simulate blockchain consensus. And we hypothesize that this would allow users to flexibly simulate protocol environments, benchmark performances, and attack consensus protocols, which would aid the exploration of blockchain scalability with respect to consensus parameters and hopefully help with the understandability of these protocols. Coming to the major features of our solution. Firstly, we create a simulated orchestration where a single simulation engine would emulate the behavior of all the players involved in the protocol. Moreover, our system would also have attacking capability where we would provide enough boilerplate to the users so that they can develop their own attacks and thwart the simulation engine's attempt to attain consensus. Keeping these major features in mind, we come up with some requirements. The system requirements would be the following. So assigning functionality to validate the identity of the players involved in the protocol, an authenticated channel where you can send and receive messages, and a simulation engine to emulate the player behavior. In terms of non-functional requirements, firstly, we have performance, because many people would use this solution to benchmark the popular consensus protocols. Secondly, modifiability. What we also want is that the users should be able to easily add more protocols to their to the system based on their needs. Thirdly is usability, where we aim to include sufficient documentation and instructions so that the solution can be adopted on a wide scale. Talking about the scope, we would stray away from real world blockchains, which can tackle thousands of users, because that would be an overkill for academic exploration and would be very compute extensive, which is not practical for the timeline of the project. What is in scope is making an open source, high performance, flexible solution available to our users that would enable them to interact with the simulation engine and gain statistics on performance or correctness of various consensus protocols among limited number of parties. Along with this, because academic exploration and understandability is our top concern, we would also develop one of the protocols that we implement into a lab exercise for the Foundations of Blockchains course taught by Professor Shi in the next semester. Talking about our design considerations, we make two assumptions on the network. Firstly, the network is the environment is static, which means that the simulation engine would be provided the distribution of the players beforehand. So there is no dynamic joining or leaving of the protocol, because that adds into the complexity of what can be implemented. Secondly, network restrictions. We would assume that there's a bounded delay and no partition in the network. This is because of the CAP theorem, which basically says that you can attain 2 out of the 3 properties in any distributed system out of consistency, availability, and the ability to handle partitions. And for now, we'd focus on consistency and availability. Talking about our architecture, on a high level, we would have a simulation engine that the user would provide the protocol arguments to. And then this engine would emulate the behavior of all the parties involved. So there'd be players and adversaries. We would also allow the users to add some of their own test cases to the adversary so that they can thwart the consensus. All the players would communicate their messages through an authenticated channel, and each sender would have to use the F-sign functionality to sign the message that they send so that the receiver can then verify the identity of the sender. I want to highlight that this design meets 2 of our non-functional requirements, where basically, because the user only has to interact with the simulation engine, we ensure that minimal details are required for this interaction, and that enhances usability. Secondly, we implement things in a modular fashion so that new protocols can be added very easily, and that adds to the modifiability aspect. Talking about our implementation overview, we selected Strong to be the first protocol that we implement. This is because it is very fundamental to consensus, and it can deal with any number of faulty nodes. Say F Byzantine nodes can be dealt with in F+1 rounds. So that was an attractive property. Also, all modern day consensus protocols have built on top of the Strong protocol. So how we go about implementation was basically implementing the player and adversary module and then extending them to, say, the DS player and the DS adversary module, which implements several features of the particular protocol. This would allow us to further expand our framework to different protocols by simply using the player and adversary modules. Coming to the test design, we would provide 2 kinds of tests. Firstly, performance tests, which would allow the user to gain insights on the performance. The user can invoke protocols under desired environment to adhere to the protocol correctness or security restrictions, and gain insights on, say, what was the view of each player involved. That is table 1, and table 2 would be the time taken for each round to complete. Secondly, we also allow attack tests where the user can implement the adversary class to attack the consensus protocol. and the output would reveal how the players involved in the protocol have a mismatch in the view of the consensus, and the consensus wasn't attained. Talking about the risks and challenges involved. Firstly, security vulnerabilities. So if we miss out on any minimal detail, we might miss out on some edge cases, or our implementation would be vulnerable to attacks. And the second one is low performance of cryptographic primitives. So there are certain primitives that are just needed for our framework, such as the signature protocol, which might slow down the entire protocol. And so we need to keep this in mind, that these details are taken care of and they're efficient enough for the implementation. Coming to our plan, we spent the first half of the semester ramping up on the technology and designing the framework and selecting tools, and also selecting the protocol that we want to implement. Currently, we are done with the implementation and are working on iterations of optimizing the protocol that we have implemented. And in the coming weeks, I'll be developing the lab exercise for the same. Once this is done for next semester, we would expand on the framework by adding more protocols, adding documentation, so that by the end of the capstone, we can open source this implementation. Coming to preliminary results, I just finished on the implementation. So right now what I'm experimenting with is the runtime versus the total nodes involved. And as I mentioned, Dolostrong can tackle F Byzantine nodes in F+1 rounds. So we don't go to a very high number of Byzantine nodes, because that would be impractical number of rounds involved in the protocol. However, what we see is that there is a polynomial relationship between the runtime and the total nodes.
So what are the units on the y-axis?
Oh, sorry. So basically the runtime would be in seconds, but that is a point. I mean, it's sorry, it's microseconds. So yeah, we see that there's a polynomial relationship between the runtime and the total nodes. And this is not so much for the compute as it is because of the message relaying part, because at each round, every honest party has to disseminate their view of the protocol to all the other honest parties. So this O of n square amount of message relaying, where n is the number of parties involved, is what adds to the polynomial relationship. Yeah, so I'll currently experiment with the runtime so that we can figure out the sweet spot which can be allowed for the lab exercise, so that the students can efficiently test and the auto grader can handle scaling of the number of students testing. So that is the plan, the next milestone that we have in mind. And that was it for my presentation. Thank you.
So I think your final presentation, I have a suggestion for you, which is this talk right now is great for somebody that's already doing blockchain. But for somebody like me who doesn't know anything at all about the details of blockchain, some of it went over my head.
Okay.
So I think you want to add some slides where you take the time to kind of lay out the background. So for example, I didn't know what signing functionality meant. Okay. So I think you want to make sure that you present all the basics so that anybody with a basic computer science background can kind of get up to speed with you. Also, I think before you start getting into the requirements for the simulation and the exercise, it would be really useful if you showed a reference architecture workflow or data flow for blockchain, just to kind of go through all the pieces and how they interact together. That way we kind of know what it is that you're then trying to simulate simulator.
Makes sense.
And it might be okay to take one of the simpler consensus protocols to understand and actually talk through it a little bit, maybe with pseudocode or something. The little graphic moving around was suggestive of what's going on, but talking through a flow chart or maybe a little piece of pseudocode. And I'm sure that this is all going to be easy for you because you've already had to learn all this stuff yourself. You just have to kind of build it into the final presentation and the final report. I don't think it's a problem at all that you're limiting the protocols to a limited number of parties, because your goal is to do simulation and to create an environment that's great for education. So one thing I would also like to encourage you to do is, if building a lab exercise is a fundamental part of what you're doing, that should actually be a first-class deliverable. So I'm kind of expecting more details on, what are you actually doing for the lab exercise? Are you doing, a write-up for the sale platform? Are you doing an auto grader? How many scenarios are you creating? How are the students going to be judged on the exercise? It's very clear that this is why your mentor is working with you, because they want you to develop this. Sure, as an open source package, that's great, but there's a very specific educational objective here. Okay, so I think you could really strengthen your work in your presentation by making those requirements really first-class requirements.
Okay.
Because I felt that there was a little bit of a kind of dual nature in what you were presenting here.
Okay.
Because once you say that one of the fundamental requirements here is that we have a simulator and exercises that can teach students how to build and evaluate consensus protocols, then everything you said about scope makes perfect sense. Of course, we have to scope it down. If your goal is to do an open source package for the world, and then you're artificially constraining it, then crabby people would say, well, why is it even worth doing if you can only do it with, very unrealistically small, numbers of participants. Also, our program is really, really positive about educational applications of data science. So you shouldn't be glossing over those details. You should actually be telling us about the auto grader and why it was hard to write the auto grader. It was the design of the auto grader.
Okay.
So all of that detail should be very transparent.
Okay.
In what you do, because you're going to spend a lot of time on it, right? So you might as well get credit for it. Let's see. That's about it. It's very interesting, and I think that it's great that we have somebody in the program working in this area. Really, all I'm looking for is that you take the time to get all the details accessible. Everybody. There was a little bit of a disconnect in the sense that you said you wanted to have the lab exercise ready in May, but then you were writing documentation in the fall. And I guess that means documentation for the open source release. So the open source release is going to come later, but you're going to have some version of that ready for the students. Okay. Are you going to work on this over the summer, or are you doing an external internship over this?
I am doing an external internship, but I think I'll find the time to make some progress.
Because I think if this is going to be for a fall course, there's another kind of risk in your schedule, which is that basically you are creating a first version of the lab exercise in May and then you're disappearing. And then the professor needs to have that ready, for August. So you didn't have milestones like first draft of lab exercise, feedback from, TAs. So normally when we do this kind of thing, it's a long drawn out process. Where we develop the material and then get lots of feedback from test subjects.
I think, as you mentioned, I've been glossing over those details, but that is the procedure that I've been following there as well, where I do have say a write-up ready and say some tests ready, but we have to see what parameters to fix in, but I'm working, but I can add those details as well.
If you have any of that already, written down, just you can email it to me just so that I feel, comfortable. I think that I don't doubt you, but I just wish that the details had been. Sure. So what have you found to be the most challenging part of all of this? Did you work on blockchain before you came to CMU?
No, I have a background in cryptography, so that's what interested me into doing something completely new. And I took a distributed system course here, so consensus was something that I was interested in as well. So but it was still challenging because I expected it to be similar to what I've been doing, but it was completely different. And in that sense, ramping up was tough. And because of the selecting the protocol was also kind of tough, because what do you narrow it down to, and what do you work on?
Well, so I think I would be guided by the educational objective.
Mhm.
So, what are the consensus protocols that all the students should be exposed to?
Mhm.
And usually that's a combination of like the well-known ones that everybody ought to know about, the classics, but then also the more bleeding edge ones that
Mhm.
are really trying to solve the more complicated
Yeah.
problems. And if it's possible for you to give them flavor of those, that, and I'm sure Elaine can be talking with you about sort of what's right there.
Mhm.
I think when you do your final presentation and you talk about what protocols were selected and which ones you implemented, it would be great if you had a rationale.
Uh-huh.
So not, oh, these were just like the first 3 I came upon,
Mhm.
but they were chosen for particular reasons. And then there's 2 ways to answer. One is for the students, but then if you're going to do an open source
Yeah.
reference implementation, there's probably things you want to have.
Mhm.
Another thing to consider is if you would like to have more students helping you out,
Mhm.
then it is certainly possible for you to advertise your project among not only your class, but the incoming class of MCDS students. Because if there's anybody coming in the fall who's interested in this, then they could do an independent study in the fall where they'll essentially be working with you.
Yeah.
And you should ask Elaine about this.
Mhm.
So, and maybe you can wait until end of the summer, beginning of the fall. But if you ask her, hey, if this is going well, Professor Nyberg said that he'd be happy to, continue having MCDS students engage on this topic,
Mhm.
even to the point of having some get involved in the fall early, doing an independent study, so that when they would start their capstone in January, they would have already had some overlap.
Yeah. Mhm.
So these are all meta comments,
Mhm.
and you're not at all responsible for building the relationship between Elaine and MCDS.
Yeah.
But if it's going well, and she is kind of feeling like this is helpful for her, I want to make sure that she understands that we think this is great.
Mhm.
I'm trying to, for the incoming class, I'm trying to promote a strategy of students not waiting until January to think about what they want to work
Yeah.
on, for capstone. So
Mhm.
we're trying to get them, engaged with the ongoing capstone. So as much as
Yeah, that'd be very helpful, just having the time to.
good. So is this area something that you want to work in after you graduate, or do you think this is kind of like a specialty? Or
So throughout my undergrad, I narrowed in completely, and I just focus on the research part. So right now I'm generalizing just to make the decision of what I want to do. But yeah, I couldn't just let go of it. So I picked up a capstone again that relates to it. But right now I'm focusing on general work.
Got it. Because there's the related question of what courses to sign up for. Are you doing systems concentration?
Yeah.
So it could be possible that there are other courses besides the ones on the list that would be relevant for you. Don't be afraid to ask Matt.
Okay.
That.
Okay.
Professor Saker, can this course count as a systems project course because of my specialty?
Mm-hmm. Yeah.
So are you thinking back to industry or maybe PhD after this?
Yeah, that's the thing. So I'll try out industry because again, I just came out of research and I joined the program. So I try out industry and then make the decision.
So where are you going this summer?
Facebook.
Okay.
Mm-hmm.
Because if you do want to apply to a PhD program, then I think you want to make sure that you're taking courses that are kind of specialization courses, and also trying to write some papers.
Yeah.
By the time you graduate, and maybe even consider switching to the 20-month program so you could have another semester of research.
Mm-hmm.
But if you're going to go on and work in industry, then it would be more, okay, how do I pick up the practical skills? Maybe you get a return offer from Facebook and you want to go work there. Then you might have this idea that, okay, for my final semester, I really want to, pick up courses in certain areas. We always have flexibility for students that want to specialize in a particular area. So feel free to ask.
Yeah, sure.
All right. Do you have any questions for me?
Not really.
All right, thanks for the presentation.
Thank you.